Welcome to the Data Future channel. This is Shekhar and I am a data scientist. So in this particular tutorial, we are going to build a machine learning model for diabetes prediction or the predictive system. So here in this particular session, we are providing patient's parameters or patient's attributes so that the system directly can predict whether that patient is having a diabetes or not. Okay, so we are using a 4 to 5 models. We are developing 4 to 5 models. Out of that, we will choose a best model and we can build a predictive system. Okay, so let's get started. So the first point is we have to import some of the parameters, some of the libraries or modules we can say, or some of the dependencies. So here NumPy pandas. Here we are importing a pre-processing the standard scalars, 10 test split as usual. Then the model. So model we will be, import later on also, no issues, and the accuracy score. Okay, so I'll run this cell. Okay. Now we are ready with our libraries. Now we have to load the data. Now the data is there inside this the folder. So I'll read this data here and I will try to see the first 5 rows here. So you can see that the data is about the patient's details. This data is containing the columns which are pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetic pedigree, function, age, and finally our target variable is the outcome, which is 0 and 1. So whether the person is having diabetes means 1 and not a diabetic person means 0. So we'll check the number of rows and columns. So 760 rows are there, means 768 patients data is available with this with 9 columns. Okay. So you can see when you use the describe functions, it will give the summary of statistics of some numeric columns. So all are numeric columns here because when you see the data set, let me just see what is the D types of this data. So you will see all are integer and the float values means all the data is the numeric one. So it is very easy for us because not much feature engineering is required here. So you can see that these are the 5 point summary we can see where you can see the mean value, standard deviation, minimum value, maximum value, 25th percentile, 50 percentile, and 75th percentile. Okay. You can check what is the target variable. So here the data is quite imbalanced, but we need not worry about that because we are building a 5 models and these models will take care of it. Okay. So if you want a greater accuracy, or then you have to balance this data. Okay. Now this is the target means not the person patients we are not having the diabetics. I'm 500 records and with the diabetic patients I around 268 records. Okay. Yes. So we'll check. I'm just using a group by function here. So I'll show you what exactly I'm doing here. I'm checking what is the mean value with respect to the target. So you can see that the pregnancies, the mean value for not having the diabetic is 3.29, and those who are having the diabetics is the 4 pregnancies, right? Glucose level, average glucose level is 109, average glucose level is 148. You can see BMI also 30, 35. So whenever you are having a greater BMI, then there may be chances of this diabetes. You will have the diabetics in future. So insulin level you can check the average one. So I'm doing the same thing. here, but I'm calculating the difference between these two also, so that I can check which parameters are impacting more. Means if there is a larger difference, then these parameters are more important for model building. So here you can see the 38% difference is there between the 0 and 1, means pregnancies are important. The insulin level is also very important here. That plays very vital role in diabetes. After that, you can see there is glucose level is also there, and the diabetes pedigree function is there, right? So these are the important features. Okay, but we are having a 9. We will keep everything here. Okay. Now, what I'm creating a data only for the predictors. Predictors means those we are independent variables. Dependent is your outcome. Okay, 0 or 1. Okay. So I will do some data visualization here. So I'm importing the Seaborn and Matplotlib, and I'm plotting all the histograms for the all the nine columns, nine variables, or nine features, we can say. So data.hist, I'm using a beans is equal to 30 and figure size is 15 comma 10, and plt.show. You will get there is a nice view of the histogram of each variable, right? So you can see that the glucose and blood pressure is kind of sort of normally distributed, but not exactly. This is BMI is also normally distributed, but rest of all are the quite as right skewed. So tail is on right side. Okay. Uh, Pregnancies we are getting its terms of pie chart. So if you reduce the bins equal to 20, then we'll check how you will get this the data. Okay, you can see uh, the data. It's again it's right skewed here, right? So you can do 10 bins and you can plot it, right? So you can change it and you can do, yes, you can see there is a nice a histogram you can see. Now you can plot box plot also for these variables, and uh, box plot will give you a nice view of the 5.70, but here we are checking the outliers. So you can see that the for every variable there is outliers are present in the data set. So you can see the points which are you can see uh, apart from this lower and upper whisker, you will see these points are the outliers, right? So you can plot one by one this box plot. Then you can check the what is the correlation among this, because with this correlation you can see that with whether it is data is correlated, then we can drop these variables also. Okay, so you from this you will see the data with the correlation. Now you can see that here there is a age and pregnancies are highly correlated, right? Not highly, but it's a 54% correlated. And here is you can see 90, 39% correlation is there, skin and the BMI there. Okay, so this correlation we are not getting any idea, but we can plot the heat map of this correlation by using a SNS dot heat map and the correlation matrix, and you will get the nice view of this heat map, and you will can easily identify the correlated variables, right? These are the correlated one. Now um, we have to check we have to separate the data into uh, the dependent and independent. So target, this is our target variable. So this is target, and uh, this is our independent or predictors we can say, because this will predict our target variable. So this is x and y. We have separated the data, but you can see the x values. So these x values are having a different scale, because whenever we are using a distance-based algorithms, the it will take a lot of time, and our results may be inaccurate because of these varied ranges. So pregnancy is having different range, glucose is having different range. So we have to bring all these variables on a common scale. Okay, and for that we are using what we can say it's a feature scaling. So you can use the min-max scaler or the standard scaler. So basically standard scaler is used for the normalist data. If data is normally distributed, then we can use the normal scalar, a standard scalar, and if it is not, then we can use the min-max scalar. But there is no any thumb rule, so you can go with the standard scalar, right? So here we have used the standard scalar, and what I'll do, I will use the fit underscore transform, and I will transform these all the x data. Okay, so you can see now the x data is scale data is look like this, means all the values on the same scale, means the each column you can see the mean is 0 and standard deviation is 1, right? The next step is we have to split the data into training and testing. So already we know that how we do that. So we are having x scared, y, test size is 20% data we are using for the testing, and 80% we are using for the training. Okay, so this is about splitting the data training and testing. You can see the shape of this. And the next part, very important, is the model development. So we have to import the models from the sklearn, and I'm importing around 6 models. One is logistic regression, decision tree, random forest, SVC, k-nearest neighbor, and gradient boosting classifier. So these classifiers I'm importing from the sklearn, and here you have to create the object of each model. So I'm creating the object of each. So these objects are ready now. The model training is there. So you have to fit the model to the training data. So I'm fitting each and every object to that training data. So we are getting all the models gets trained here. So model training is done. Now you have to evaluate the model. So model evaluation phase will start. And for that, what I'll do, so I'm importing here classification report, but we will do classification report later on. So in that, you can check the training accuracy and the testing accuracy. Okay, so I'll show you for one example how that evaluation takes place. So I'll use the YPRED, and I will use this logistic regression first. So logistic regression dot predict. So that prediction should happen for the X test. So you will get the Y predictions. Okay, here. So you will see the Y predictions here. Yes, these are the Y predictions. Now we have to check the accuracy, because you have to find the accuracy score. Uh, okay, from sklearn dot matrix import accuracy score, and you have to use that accuracy score, and what parameters you have to go, y true. So y true is actually y test, and this is y predictions, and from that you will get this accuracy. You can see the accuracy is 71.42. So this is the testing accuracy. Okay, so you can do it for every model. So here there is only change is the model, and you have to use that prediction for this. And you can use that classification report also. So classification report. So let me just classification report, and the same you can do it for this training and testing. Sorry, this for logistic regression, and I'm printing this classification report. So from these classification reports, you will get the all the values, right? Precision, recall, F1 score, and support. So you are here you will get the accuracy 71%, and you can see there is a difference between this recall, F1 score, and precision. So based on that, you can select this. Okay. So this is the medical problem. So you have to keep your recall high. Okay. Okay, fine. So, yes. And now the next thing is I'll check both the accuracies for each model. One is training accuracy, and the second one is testing. So I'm using the dot score function. So I'm having this model dot score, and I'm providing the extend white train and into 100, and I'm round off to two digits after decimal, so 79%. And testing accuracy, I'm changing x text y text. So only you have to take care of the dot score function. So you can see this is the testing. So I'm using this same concept for all the models. Now I'm preparing it for logistic regression first, then I'm changing a decision tree model. Then you can see this is the accuracy, but you can see that in the decision tree, the training accuracy 100 and the testing is 73, means it's overfitting. The model is overfitting. The here is the less overfitting. This is working fine. For next one, we'll check 175. Again, it's overfitting is happening here. So we'll check the SVM. SVM is good fun. So it is giving a good accuracy with training accuracy. So there is not much difference between training and testing accuracy. And here this KNN is also good, but its testing accuracy is less. And for gradient boosting, we are getting 91 and 74, again 75. Yes, this accuracy is good, but again, this 91 and this is having quite a great difference. Okay, good. So we'll check it by using a cross validation. So what we can do, so we will cross validate these models so that we will get the true accuracy. Okay, so I'm importing this stratified k-fold with which we can create the number of folds and cross-val score. Okay, so I'm using it for the logistic regression. I'll show you for logistic regression cross-val score. I'm using all the data x scaled, y scaled, CV is equal satisfied, and I'm using a five-fold. So I'm getting a five accuracies, and I'm taking a mean of these five accuracies. So you will see the mean of these five accuracies will be a 77.08. Okay, I'm doing this for all the models. You can see I'm changing the model only here, and yes. So all the accuracies for these models are ready. Okay, and I'm printing the model cross validation accuracy for each model. So I'm round up this the accuracy to the two decimal spaces. Now you can see the mean cross-val accuracy for each model, and here you can see the 77% accuracy we are getting for the SVM model. So it's a good sign. So SVM we are using for the model prediction. So what we'll do, so we will use this best model, that is the SVM, for the predictive system. Now we will do the create the predictive system. Now in the predictive system, what we want the inputs from uh, based on these columns. Okay, so I have created here. I'll take the user input, and I will put the user input by using this and create this data. So I'll show you one by one. Number of pregnancies, I'll put one. The number of glucose level is 120. Then blood pressure is 140. Then skin thickness is 34. Then insulin level is 89. Then BMI is 23.5, and this function is 0.67, and age is 45. Okay, now you can see this data is ready, but this data cannot be directly used for the prediction. So what you have to do, you have to convert this data into array. Now you can see this data is converted into array. Now this array we have to reshape into a two dimensions. Yes, now it is converted into two dimensions. Okay, reshaped it by using a reshape 1 comma minus 1. Now we have to transform the data because we have to use the scalars. Right here we have to use the scalars. Now this data is scaled because we cannot directly use this data because this is having a different range. Now data is scaled. Now this data is used for the prediction. So I'm using SVM model dot predict. I'm providing this data. So you will get the prediction. So prediction is 0 means this person is uh, not having diabetes. So you can use the slice this and get the result as 0. Result is negative means it's a non-diabetic person, and result is 1 means it's a diabetic person. Okay, so when you run this, and you will see this person is not diabetic. Now I'm putting all these things into a single this thing. So you can see. um, okay, so I'll run this and I'll check. Okay, so first I will put the data for this uh, first data, that is 5. Then second one is 166. You can see data, this data I'm putting, inputting. Then 72, 19, 175, then 25.8, 25.8, okay, 0.587, 0.587, okay, and 51. Age is 51. Okay, age is 51. Now you can see that the machine learning model predictions are result is positive means this person is diabetic person. So whatever the values you have entered here, this patient is diabetic patient. So you can try your own values and get the results from this predictive system. So this is all about the diabetic predictions. So you can develop your own model. You can do the hyperparameter tuning and select the best model. Okay, that's all from my side. If you have any questions, you can just ping me or just subscribe my channel. Thank you. Thanks a lot.